In the previous lecture, we have discussed some application of circle. Now, I am going to start from the point where we have ended the last lecture. The change in velocity when a particle is moving along a circle, let us say from point A to point B, where these 2 points make an angle theta at the center, was given as the magnitude of change of velocity was given as 2v into sine theta by 2. On the base of this equation, I am going to give a very simple question that first you have to solve by pausing the video, and then if you are not able to solve, you can just go through the remaining part of the video in which we will discuss the solution part. Now let us say a particle, or let us say minute hand of our watch is moving. Let us say from a point where the time is given as 12 noon. Now it moved to a point when the time becomes 3 p.m. If the velocity during this motion is given as, let us say, 2 meters per second, can we say that there is a difference in velocity between these 2 points? And if yes, you have to calculate the change in velocity in the given case. Just pause the video and start solving this. Now, you must have tried this question. Whether you are able to solve it or not, you are able to solve it, that is good. If you are not able to solve it, then Subbu sir is going to discuss the solution of this question here.
So here the angle which it has travelled is 90 degree. 12 p.m. to 3 p.m. there is a 90 degree angle which the minute hand has covered. And the speed is 2 meters per second. Actually this 2 meters per second is a very huge value. We know that it is not possible that a minute hand in 1 second travel 2 meters, but still we are not concerned with that. So basically we have this as the speed, this as theta. So what is the change in velocity when the minute hand was here and when the minute hand is here? So this is a point A, this is a point B, and these are the directions. So delta V is actually 2 into V, which is 2 meters per second, into sine theta by 2, which is sine 90 degree upon 2. So you will get sine 45 degree, and sine 45 degree we all know that it is equal to 1 upon root 2. This is 4, this is 1 upon root 2. So overall we will give 2 root 2 meter per second is the magnitude of change in velocity actually.
So you can see that just by knowing the formula of change in velocity, you can easily calculate the value of the change in velocity. Now, I am going to discuss another part in which we are going to apply the formula of change in velocity during uniform circular motion. You must have heard a term that is called centripetal acceleration or centripetal force. What is centripetal acceleration? So whenever a particle is moving along circle, it has 2 types of acceleration. One is called centripetal or radial acceleration, that is the acceleration along the direction of radius. And the another is called tangential acceleration, that is when speed is changing, the direction of acceleration is also along the tangent of the circle. Here we are going to discuss a case when the speed is constant, that is the motion is uniform circular motion. Then what is the value of centripetal acceleration? Because in that case, tangential acceleration, which is given as a tangential dv by dt, since speed is constant, so a tangential is 0 here. Only acceleration in this case will be the centripetal or the radial acceleration, which I am going to discuss here. Now, when particle move from point A to point B, change in velocity is given by this formula. What is the amount of time taken by this particle during motion from A to B? So time taken is simply distance covered, that is AB, upon the speed, that is V here. What is the value of distance covered AB? This was also discussed by Subbu sir in the previous lecture, so you can just go through that lecture. And the value is simply r into theta upon V, where r into theta is the arc length AB, when theta is angle subtended at the center by this arc AB here. Now, what is the value of acceleration? It is simply change in velocity upon total time taken. So change in velocity is 2v into sine theta by 2 divided by r into theta upon v. So I can write this as 2v square upon r into theta into sine theta by 2. This is a very general result for any value of theta. Now if I want to make this theta very small, that is when theta is very close to 0, for value of angle theta less than 2-3 degree, the value of sine theta comes out to be almost equal to theta. So I am going to use that relation. You can also go through the table in which value of sine theta is given. So theta and sine theta are very close when theta is less than 2 or 3 degree angle. So here for smaller value of theta I can write 2v square upon r theta. This term, that is sine theta by 2, will simply becomes theta by 2 here. So theta will get cancelled out and 2 will also cancel out. This is simply v square upon r. So this is the value of centripetal acceleration when the particle is moving with uniform speed along a circle. Centripetal force. What is centripetal force? Centripetal force is mass into centripetal acceleration. So it is simply m into v square upon r.
This is a term which we generally see in physics.
Yeah, centripetal is a very common term whenever a particle is moving along a circle, like when we take a turn, when we are moving through a vehicle and when we take a turn, we generally experience a jerk in our body. What is that jerk? That jerk is due to inertia of our body, and that is due to centrifugal force, that is opposite of centripetal force, and that the magnitude of centripetal and centrifugal force is same, that is mv square by r. For any particle to move along a circle, this particle must be given a force which is equal to centripetal force, otherwise the particle will not be able to complete that circle. So this is a very fundamental of when a particle is moving along a circular motion. So now I am going to give you one very simple question based on what we have learned or what we have discussed in the last 2 lectures. Let us say a particle is moving along a circle whose radius is given, let us say, as 1 meter, and the mass of the particle is given as 2 kilogram. The speed of the particle is constant and the value of speed v is given as 2 meter per second. So you have to solve this question just by going through the formula that we have discussed here. In the next lecture, I am going to discuss the solution of this question as well as some other concepts of circular motion. So thank you for this lecture, students. In the next lecture, we will come up with some other concept and solution of this problem.